what we did in section 1 is we talked about sampling distributions in general. Today we're only talking about the sampling distribution for mean. Two most common statistics are sample mean, sample proportion. So in this section we're going to do sampling distribution for sample mean, and then in section 3 sampling distribution for sample proportion. So sampling distribution for sample mean, there are 4 important properties. Okay, first one is that the mean of the sampling distribution, so that's mu sub x bar. So if I take the population mean of all of the sample means, so the mean of the sampling distribution, that's going to be equal to the population mean. So that property you've already learned. Second property, the standard deviation of the sampling distribution. So I found all the sample means and then found the standard deviation is equal to the population standard deviation divided by the square root of n. Okay, third one, if the population is normal, the sampling distribution is also normal, regardless of the sample size. Last one is the central limit theorem, which you guys already wrote down. If n is large, so greater than 30, the sampling distribution of x bar is approximated by a normal curve, regardless of what the population looks like. Okay, so you need to know the different shapes of sampling distributions. So there are 4 cases. The population is normal or not normal, and then you either take a small sample size or you take a large sample. If the population is normal, the sampling distribution is always normal. Doesn't matter what the sample size is. So population normal, small sample size, that means that the sampling distribution is approximately normal. If the population is normal and you take a large sample size, the sampling distribution is still approximately normal. Okay, it gets more interesting if your population is not normal. So you have a population that's skewed or bimodal or uniform or multimodal or something like that. If the population is not normal and you take small sample sizes, so samples of size 10 or anything below 30, we don't know what the sampling distribution will look like. If the population is not normal, but we take large samplings, so samples bigger than 30, then the sampling distribution will be approximately normal. And that's what the central limit theorem says. So that one box applies to the central limit theorem. So basically what you're looking for in any problem I give you is the population normal, or did I take a sample size bigger than 30? Questions? Okay, the way you're going to see this is like this last question here. So ACT scores are normally distributed with a mean of 22.1 and a standard deviation of 4.7. So that's talking about the population. What is the probability that a randomly selected sample of 5 students will have an average score of at least 25? So this looks similar to what you guys did before in chapter 7. I have a normal distribution, so I'm going to have to do normal CDF or use a table or something like that. But here's what's really important is that it tells you that it's a sample of 5 students and an average score. So this question is asking, what's the probability that my average score, my x bar, is at least 25, so greater than or equal to 25. That means that we are looking at the distribution of x bar, not of x. Okay, because ACT scores are normal, that means the sampling distribution is normal. The mean of the sampling distribution is just the population mean. The population mean is 22.1. Standard deviation of the sampling distribution is the standard deviation of the population divided by root n. So that's 4.7 divided by the square root of 5. You might want to get out a calculator. So that's about 2.102. Somebody confirm that? Okay. So now we can convert this to a z-score. Again, the only reason that we can do that is because the population is normal. So the population is normal, therefore the sampling distribution is approximately normal. You can't just use a normal curve whenever you feel like it. So you have to verify that the sampling distribution is normal. Here it is because the population is normal. So when I convert to a z-score, that x bar becomes a z. And then I have 25 minus 22.1 all over 2.102. I got 1.38 about. Okay, don't write this, but this is what you're going to put in the calculator. You're going to do normal CDF 1.38, comma, positive infinity, so 1 times 10 to the 99th, comma 0, comma 1. And we're looking for an upper probability. I got the probability to be about 0.0838. You guys get the same thing? 0.0838. Yes? No? Okay, thank you. So about 8% of the time, a sample of 5 students has an average score of at least 25. Does that mean that each student has a score at least 25? No, average. Okay, so this is what a lot of students do when they see this question. They find the probability that x is greater than or equal to 25. And then whatever answer they get, they just raise it to the 5th power. How's that different? I'm going to tell you they're not the same. So why can't I just find the probability of one person being greater than or equal to 25 and then raise it to the 5th power?
That's the probability of all 5 of them having above 25.
Exactly. Yeah, that's the probability that all 5 students are going to have a score of at least 25. We're talking about an average. Does this make sense? Mm-hmm. What's one other thing that I'm going to make you do? Draw a picture. So let's do it just for fun. Yours should look better than mine because I wrote way too big. So make sure you have the standard normal labels. And then below that, label from the problem. Okay, so here's where you got to be careful. Make sure you use the correct mean and the correct standard deviation. So our mean is 22.1. And then this is the standard deviation you want to use, that 2.102. So that's going to be 24.2, 26.3, 20. So 25 falls about here. And that's a z-score of 1.38. And I'm looking for everything above that. Remember that I want you to draw a picture to make sure that your answer makes sense. So our answer is 0.08. That figure looks like about 8%. Okay. Do we have any questions from this section? None at all? We're 100% good. Okay, can I erase what's on the board? Okay.